My name is Paul Yu. I am a cloud native developer advocate at Microsoft. And one fun fact about me is that this is, although scale 21x, this is scale 2 for me. So I was actually here last year as an attendee, and I was like, wow, this is a pretty cool conference, got some good people. And I said to myself, you know what? I'm gonna come back next year, and I want to speak. And so here I am. And today I'm going to talk to you all about strengthening the secure supply chain using open source tools. And so my goal for you is basically to give you a tour of some of these tools because they can be a little daunting to get started with. And so I'll be doing a live demo. I will be testing the demo guides today and also testing the conference Wi-Fi. This is the last day of the conference, so hopefully the Wi-Fi will be good to me. Let's go ahead and dive right in. So first and foremost, strengthening the secure supply chain. This is going to be focused on container security and taking that container security and making sure we're patching them and delivering them to container orchestrators like a Kubernetes. And so whenever you think about Kubernetes, you're always thinking about containers first and foremost. And of course, containers are awesome. They're awesome because they create a consistent and portable environment. I spent a lot of my time in the, I would say the .NET, the Microsoft stack, that ecosystem. And back then, ooh, it was really painful to deploy your application onto the servers that you needed them on. Back in those days, I was doing MS Build, packaging them up into zip files, and then literally copying and pasting them to every single server, unzipping them, and praying and hoping that the server would have the right dependencies that I needed for my application to run. And if you've worked in the .NET framework days back then, if you were missing a DLL or if you overwrote the wrong DLL, man, your application is cooked. So I would say when the concept of containers came out, it was like magic. Like, you layer in the operating system, you layer in the application dependencies, and then boom, you have an application in a nice containerized thing that you can take and deploy into every single server that you need it to. And so that was like super cool. What that gives you is that also gives you the ability to easily manage and orchestrate these workloads so you can actually deploy them using things like automation and orchestration. I mean, that's what Kubernetes is all about, right? And so what you get is you get your application that is highly scalable. You can deploy them out to literally hundreds, thousands of servers, like with a single command if you really wanted to, right? And they can also improve your security. But because it's highly scalable, that means your application, the blast radius is also super wide and big, right? If your application is highly scalable, then so are your vulnerabilities. So as you're shipping your app, and if your app has vulnerabilities in it, then unfortunately so do your applications wherever you deploy it to, right? And so we're living in this world now where there's just security vulnerabilities galore. I mean, I think we're at a point where there's reporting, we're reporting about 50 plus CVEs on a daily basis, and it's just like a never-ending game of whack-a-mole, right? So like this cat here, just constantly, patting down the fingers, and it's just a never-ending game, right? Just to illustrate the point here, you can see that the number of security vulnerabilities that were reported just last year alone. This report was taken by Qualys, a threat analysis report, and it was generated about mid-December or so. You can see that there was 26,000 CVEs reported in mid-December. I think we ended the year like under 28,000 CVEs, but in any case, you can see that the number has jumped an alarming rate. And starting from the year like around 2017, you could probably attribute that to cloud-native workload adoption. Could be due to other reasons, but the point is we're seeing this huge spike in vulnerabilities that are being reported. Now, not to alarm you too much, but out of that 28,000 or so CVEs that are reported last year, not all of them are highly critical vulnerabilities. There's only a small portion of that. But even if you start to look at the vulnerability types with the high critical vulnerabilities, you can see that a large portion of that is due to the operating system, right? And so that's where we're going to focus our container security story here, and just basically looking at ways that we can secure that operating system inside of the container and make sure we can deploy that out to our servers in a timely manner, okay? So where do you start? When it comes to Kubernetes and the CNCF landscape, it can get a little bewildering, but at the same time, Cloud Native is pretty cool because it's like all the tools that are out there, to me, it's like Lego blocks, right? I spend a lot of my time as an Azure architect helping customers onboard to Azure, and it's like, where do I start with these services? I don't know where to start. Same can be said about the Cloud Native landscape. They're all just different open source projects that you can pick and choose from, but where do you start? It would be nice if all the building blocks were just like this and they just snap together. They're all the same shape and size, but it's not like that. If you look at the Cloud Native landscape diagram and you see literally it's littered with hundreds, maybe not hundreds, I'm exaggerating, but it's littered with a lot of projects in that CNCF landscape diagram. And that diagram starts to feel like this to people, right? And these poor Lego heads that are somewhere in the rubble, that's probably a Kubernetes administrator somewhere just like, you know, like it's just too much to pick and choose from, right? So where do you start? We're gonna start here. And I took a subset of that CNCF landscape diagram, and I wanna highlight a few projects that you can take a look at to strengthen your secure supply chain, okay? First and foremost, I wanna focus in on Trivy. If you've worked in the Cloud Native landscape, you've probably heard of Trivy before. It's a great vulnerability scanner that you can actually leverage within your whole ecosystem. It's not a CNCF project per se, but it's a highly used Cloud Native security scanning project. The next thing I want to focus in on is this project called Copa. And I'll get into a little bit of the project details in a little bit, but I do want to focus on Flux as well because we're going to be leveraging that for our automation bit. And this project down here called Eraser. One special shout out I want to make, I'm not going to demo in this talk today, but I just want to specifically call this out as Notary. You can use this to actually sign your container images, and then you can use other applications to actually do the attestation and do the signature verification. So, but all the blocks that you see in pink there highlighted, if you can see that color, that's what I will be demoing today. One other project that I did not talk about that wasn't on that landscape list is GitHub Actions. GitHub probably needs no introduction. You probably know it already for its CI/CD capabilities. Actions is basically its workflow platform where you can trigger workflows based on certain events, whether it's a push or a PR merge or a schedule. And these runners are typically running in GitHub Cloud, but you can actually self-host that if you wanted to. Just to quickly touch on Flux as well. This is a pretty old project within the CNCF landscape. Donated to CNCF in about 2016 timeframe, graduated in 2022. This is basically your continuous delivery solution for Kubernetes. And I think they actually coined the term GitOps, right? Or actually Weaveworks did. Special shout out to all the Weavework folks. I know there was some, they went through a little turmoil, so hopefully everybody landed on their feet there. But what we're gonna do is we're actually gonna leverage Flux, a feature inside of Flux called Image Update Automation. And we're gonna use this to actually detect new images and make changes so that we can deliver that new version of the image as soon as possible. The other project I wanna highlight here is a CNCF sandbox project, donated in 2023. What this is I like to call this the Roomba of your Kubernetes cluster. It'll actually just float around your cluster and pick up any unused, vulnerable container images and delete that from you, right? Because within Kubernetes, they do have this almost like a garbage collection type capability, but that's based on load. So once your disk space exceeds a certain threshold, that's when it'll actually delete that container image. But in our case, we want to delete this thing as soon as possible because we don't want any vulnerable images hanging around in our cluster. It actually supports Trivi-scan, so it'll actually scan the containers. If it detects vulnerabilities, it'll get rid of that for us. This other project, and I've actually listed these projects in chronological order in when they were donated to the CNCF. So this is a project that actually came out of the Azure or Microsoft open source incubations lab. This project is called Copacetic, and it was donated in late 2023. The job of this project is to basically use Trivi vulnerability outputs and patch container images based on OS vulnerability scans, right? So the whole idea is sometimes as an organization, you can't really wait for upstream to fix that container image for you. You have to go ahead and patch that thing yourself, right? And so what this project will do is it'll scan for vulnerabilities. If it's known that there's a fix out there, it'll apply the patch as a layer and not have, you don't need to rebuild that entire container from scratch. So it's a really quick way to get your OS vulnerabilities fixed, and that's the whole point here. Okay, so enough talking, on to the demo. What I will be doing today is I'm gonna do this live, and I said I'm gonna test the demo guide, so we'll see what happens. What we're gonna do is I'm actually going to deploy a local Kubernetes cluster using Kind. I'm gonna bootstrap that cluster using FluxCLI. I'm gonna run, well, FluxCLI will deploy my demo application. And then I'm gonna run Trivi on one of the containers in my demo application, and we're gonna see a vulnerability. We're gonna use Copa to patch that container, and then I'm gonna deploy that patch container, and then, yay, we're all safe, right? But that's like half the story, because a lot of that stuff is gonna be manual work, and nobody likes manual work. We all want bots and AI and things like that to do the work for us. So I'm gonna configure Flux to actually use image update automation to basically listen for the new container image tags, and then automatically deploy that into the cluster. So you have like this nice continuous cycle of constantly patching your container images as vulnerabilities are found. And then finally, we're gonna get that Roomba in there, and it's gonna go around and sweep up all any other vulnerable container images. So let's see. Let me close this slideshow real quick, and then hop over to my demo. All right, so the first thing I'll do is I will create a Kind cluster. So this is the part where it probably takes a little bit of time, so just be patient with me. And we'll wait around. And by the way, as we're waiting for this stuff, if you have any questions, just feel free to shout it out, and I could kind of answer along the way. So just wait for that. Yes?
Compliance support, thank you. And one of the things that application teams are telling me is that it's not easy to update modules within the image that they're using for the containers. And they have to find a patched up version of that and redeploy the whole thing.
Right.
So what if I understand correctly, you're saying that these tools that you're demonstrating will help patch them in place on a needed basis.
Right. But this Project Copacetic tool will patch OS vulnerabilities only for now. If you have an application vulnerability, you probably just need to just rebuild your container at that point. So yeah. Right. Yeah.
So you said that it patches the OS vulnerability by adding a layer on top of the existing one rather than rebuilding it from scratch?
That's correct. Yes.
Okay.
That's correct.
And normally the OS then is referred to sometimes as the base layer, but it just overwrites it then essentially.
Yes. Yeah.
Got
and
it.
I'll demonstrate all that for you, and you can actually see the layer there.
Okay, thanks.
Yes. We have a question in the back.
Hi. So based on what you just said about the patching, given a project with a Docker file, for example, for the container, if I have a new deploy of that project, or if I rebuild the image for the deploy purpose,
Yeah.
this is not going to be patched until all this pipeline finds it
Right.
and patches it as a new container that is running. So
Right. Right.
does all these contain a way to I imagine that if there is a patch to the operating system, there is also an updated base image from which you can build your container. So
Yeah.
is there a tool to also eventually update the Docker file or container file to point to an already up-to-date operating system tag
Yeah.
in order to have it already patched when you do a new deploy or a new build of this image in
Right.
a CI/CD pipeline or whatever?
So you're asking like, how can we update the base images to the appropriate numbers? There isn't a CNCF project that I'm aware of that will do that. I've seen things like, I was at the DockerCon that was here in LA a couple months ago. I think they came out with like a Docker Scout application. So that might be able to do it, where it says, hey, your base image is out of date. You should bump to this number, and they could probably do that for you. The purpose of the Copa tool is primarily for, you can't wait on the upstream container images to be rebuilt, and so you just have to add a patch layer on top of that. So it's more like a stopgap.
Yeah, I'm thinking too about Dependabot on GitHub,
Oh yeah,
something like that, so that given patches,
Yeah.
once there is an updated version of the image,
I see what you're
you
saying.
get an alert, hey,
yeah,
change the version to
Yeah.
this one, so you address
Yeah.
those vulnerabilities.
Yeah,
So
yeah.
maybe not a major patch, but a minor patch that
Right.
addresses vulnerabilities.
Right.
So maybe Dependabot is, no, I never saw a report from Dependabot for that, so I don't think it's included in GitHub, but will probably be useful in that.
yeah. No, that's a fantastic idea. Have a Dependabot-like capability for the container images or base layers. Yeah, yeah. Now I could take that feedback back to the team that's actually working on it. So yeah, good idea. Okay, so looks like our kind cluster is actually running, and so let's just do some more testing here. I'll go ahead and now bootstrap my cluster for Flux, right? And so I'm using the Flux CLI. I have a local Kubernetes cluster. It doesn't have anything installed in it right now. And so what I'll do is I will use Flux Bootstrap to actually point to my GitHub repository where my manifests are. And so this also takes a little bit of time. And so we'll just have to wait on that. And sometimes it goes fast, sometimes it goes slow. So we'll just be a little bit patient here. Fun fact. You probably guessed that I'm not really typing all this stuff because there's a lot of typing going on. So I just want to give a quick shout out to Paxton Hare. He has this repo on GitHub. I think it's GitHub/Paxton Hare. It's called Demo Magic, and you can literally just script out your entire demo. It's actually running the commands for me. It's just I'm not typing it, because we all fat finger stuff every now and then. It's called Demo Magic. Demo Magic. Yes, yes, yes. Yeah. If you want, I could just switch to it real quick. So this is the app that I'm actually deploying, and this is it right here. So special shout out. Thank you. You saved me a ton of time with this stuff. Cool. All right, let's see. Hey, look at that. So all the components are healthy now. Let's go ahead and check the status on that. So we'll check the deployment. We'll do a kubectl get pods, and you can see that I have a bunch of pods running in this sample demo. Containers are creating. I'm pretty sure it'll be fine. So let's just go ahead and move on. So now, Git just bootstrapped itself, and it has all these, it actually written like 3 commits into my repo. So I'm just pulling down those files, so I have the latest. And then what I'll do is I'll actually scan one of my container images. And I know this one has a vulnerability, so I'm going to demo this for you. So it's called a storefront container image, and I'm actually going to use Trivy to go ahead and scan that. So when I scan this, this is another part where I need to wait on the internet to download the database, and then it'll do a trivia scan, and then we can see the output here. Not that big of a file, so it should come through very soon. Okay. So there we go. Font is a little wonky, so let me just drop this down a little bit. So if you can see here, it detected one high severity, right? So one high and then one medium. But they're all marked as fixed, and there's a fixed version for that, right? So what I can do is I can run this command again, but this time I'm actually going to rescan, but output the trivia results to a JSON file. Because when Copa does its thing, it's basically going to read that trivia output file and then basically patch based on what trivia says is the latest patch number, okay? So now that I have the trivia file output as JSON, what I'm gonna do is I'm now gonna call Copa, CLI, and it's gonna patch my image based on that JSON file. And I'm gonna tag it, as you see here, using a new version called 1.2.1 because my original was 1.2.0, right? So right here. Okay, so we'll wait for that. And you can see down here that it ran an APK update and an APK add and an upgrade. So that's the patching process, okay? So now, if I can get back to, nope, there we go. So now if I view the image history, you'll be able to see that these are all the layers that existed previously. And the latest layers are right here, these two things right here, okay? So what I'll do now is, now that I have a patched image, I can scan it again using Trivy. So when I scan my 1.2.1 image, it should show up as being, we're all in the clear, right? So now there's no more vulnerabilities, no high, no mediums, we're good to go.
So where is this patched image living? Is it in just the local Docker registry, or
It's in my local
is it
Docker
possible
registry.
if you're using, some other external registry that it would put it there for you?
Yes, and so, well, that's what I have to do as an administrator, is the next step I'm doing here is I'm gonna log into my GitHub container registry, and I'm actually gonna push that new patched image into the GitHub container registry. But check this out, it doesn't need to patch the entire container image. It's only gonna push the two layers, yes. So then when you see, you can see that all the layers already existed, and it only pushed those two different, those two new layers, which makes it very nimble in terms of like pushing our changes out. Okay, so what I'll do is, now that I have a new version out there, I want to update my Kubernetes cluster to actually use that new image, okay? And so I'm using customize here because my workload is all backed by FluxCD, and FluxCD basically listens for changes in my GitHub repo. And I'm basically saying, hey, you know what? Let's use customize to bump my version number up, and let's go ahead and commit and push that change. And as soon as I do that, FluxCD will actually kick in and then push that new image out to my Kubernetes cluster, okay? So the new manifest change has been pushed up, and if I do a kubectl get pods, what you'll start to see is we will see this pod go away and a new pod come online. So we'll just be a little patient here, and it will eventually come through.
While we wait, there is support for multiple tags. So going back to my previous question, we may tag the patched version also as latest, for example. so that we, during the deploys, we always point to latest,
Yeah.
and we don't care about the current version we declared.
Yeah.
Is this something feasible or suggested, non
Yeah.
suggested?
It's probably not, well, it depends. What you want to do, or I'll tell you what you don't want to do. You don't want to patch on top of a patch, right? So what you want to do is you always want to start with an image that has a proper base, base image versions, and you always want to work off of that. And so I'll show you in my strategy just for this demo that I approached, but basically I don't want my patch versions to be latest because I want to always ensure that I can find the image that should be the appropriate ones and then patch on top of that, right? Yeah, because you don't want to get into a scenario where you're constantly patching, and then you lose sight of like where my original image was. So it could be latest, it could be something else, but I would recommend that you mark your golden, images at a specific, with a specific tag, and then you can always just work off of that instead. And I'll demonstrate that in a bit.
Thank you.
We can see that the new container image is actually running over here. And so I will just drop out of this watch, and then let's go ahead and confirm that the new image is actually running in our Kubernetes cluster. So there we go. We can see down here that we have the 121 image, right? So there, Flux did its thing. That's cool. What I want to do next is, that was a completely manual process, right? I'm patching, I'm pushing, I'm updating a manifest, and then Flux does the automation thing. But I don't want to do that manually. I want Flux to do that on its own. And so what I could do is I could actually leverage a feature of Flux called image update automation. And I'm pretty sure Argo CD has a very similar capability. But what I want to do is I want to tell Flux, hey, my image repository is over here. Go listen for that, right? And while you're listening for that, I need to tell Flux, hey, here is my tagging strategy. I'm using semver, right? So anything greater than 1, I know it's kind of like cut off, but anything greater than 1.0.0, right? So I'm putting together like my tagging strategy, and this is how Flux is gonna know, like, oh, you started from 1.2.0, now there's 1.2.1, that's the latest, right? So that's the image policy. So the image policy will know how to evaluate tags and then determine what the latest should be. The last little bit here is using Flux image update automation, because once Flux knows what that latest tag is, it also needs to know where within my repository it should be making manifest changes, okay? And so here I'm creating an image update, and I'm basically saying, take a look at this folder within my repo, check out the main branch, and you can point this to whatever branch you want. But then here is my authoring template, because it's going to make a change to my manifest files, and so it's going to need to write a commit into my repo. So that's what that's all doing, okay? And so we will give this a little bit of time, waiting for the image update automation reconciliation process to happen. This is usually quick, but there we go. Okay, final thing that we need to take care of in order to tie all this automation together is Flux knows now where to make the edit, like what file. Now it needs to know, okay, I don't want to update the entire file. I only want to update certain pieces of that file. And so what we're going to do is we're going to have to add markers to our customization YAML. And this is a Flux thing. So what we do is, and I'll show you a diff here to see what I just pulled in. So you can see here that we're adding this tag or this comment, right? So image policy, and we're pointing to the image policy that we just created. So that will update the name for me. And then this is important right here. So we're going to add this marker that says, hey, anytime you find a new tag, go ahead and update this. So it's 121 right now, and we're going to make sure that it constantly updates that piece of the manifest, okay? So if I commit and push this to the repo, I'm now at a point where I have the full end-to-end automation in place, but I don't have the patching component in. So let's go ahead and add that. And to add the patching, right, and to your question about, how can we get this patch container up into a remote container registry, well, we can do that using GitHub automation. And so I'll pull in this sample workflow that I had, and let's take a look at the workflow. So if you can see here in the workflow diagram, what I'm doing is I'm basically scheduling this. Who remembers Patch Tuesdays? It was a terrible day. But yeah, Patch Tuesdays is when we're going to run this thing. And what we're going to do here is we're going to leverage a couple of GitHub actions that are available in the GitHub marketplace. And so what I'm doing here is, number one, is I'm finding the latest tag. So to your question about using latest, you just need a tag that you can find, that you can determine that's where you want to patch from, right? And so what I'm doing here is I'm finding the latest container image, regardless of if it was tagged as latest or whatever, but I'm finding the latest semver, and I'm going to bump that, okay? After I bump that tag number, I'm going to use that for my patching. When I run the Trivi scan, I'm not going to scan off of the latest semver number. I'm going to scan off of latest. So this is my unpatched container image, and I'm always going to patch based on that. And then I output the Trivi report. I check the vulnerability counts. And then down here, if the vulnerability count is not equal to 0, then I'm going to run the Copa action to actually patch based on my latest, right? So that goes again to the point of, not patching on top of patches. We'll always patch off of latest, okay? From there, I'll use GitHub to actually log into a GitHub container registry, and then I will retag using my bumped semver tag, and then I'll push it back out to the GitHub container registry. And now remember, this will get the new container to the GitHub container registry. Flux will listen to that container registry and say, oh, hey, I have a new tag. This tag is going to be 1.2.2. And then that's when Flux says, oh, I have a new tag. Let's go ahead and automate the whole deployment rollout. So with that, the workflow is in place. You can kind of see it doing its thing right now. And just to show you what's going on, we can also look at it over here in the actions, and we can see that there's a patch going on. And if I click that, oh yeah, you can see it. It's running the Copa action. Actually, that finished. That was pretty quick, and it just pushed the patched image. So at this point, it found a vulnerability again, because remember, I'm always patching based on the latest, and I'm running this at based on a cron schedule. So this will run like once a week, and it'll always find the patch until I update that base layer in the Docker file. That's when I'll really fix the issue for good. Okay, so from there, I can force the reconciliation of my image repository, and to be honest, I think Flux already took care of this by now. You can see that it scanned and it found 6 tags from my container registry. And then I can check the image policy. So I'll do a kubectl describe, and you can see here that it updated from 1.2.1 to 1.2.2, so Flux took care of that. And if I force the image update reconciliation, again, I'm guessing that this happened already, so this should be relatively quick. Maybe not. Because by default, Flux will reconcile every minute, and you can configure that to whatever you want. Or I can use a Flux reconcile command to kind of force this thing through. So we will wait on that. There we go. Yeah, no updates made because I'm guessing it kind of did that on its own rather through my reconciliation. So let's go check it out. Theoretically, at this point, my manifest should be updated. There we go. And then I'm going to force that customization to be applied to the cluster. And if now I look at this, get flux commits, there we go. You can see that there was a change made to my customization YAML, and Flux actually bumped that version for me. So now I have a new version in there, and I can watch the pods roll out. And it's probably too fast for me because you can see here that I have this pod, which is now 20 seconds old. And if I go ahead and verify that new image, should say 1.2.2. There we go. So now I'm fully automated, right? I now have a process in place in which I can continuously scan my images and have those patched so that I'm always running non-vulnerable, at least from an OS perspective, container images in my cluster. The last bit that I wanted to show you is that Roomba, right? So if I do this command against the nodes, and I'm only running a single node cluster here, but you can see that images, they're just cached and they sit on the server for as long as they need to until Kubernetes decides that it needs to clear out some storage space. And so you can see here I have a 1.2.0 and a 1. These are unused containers, and we know that the 1.2.0 is vulnerable, so we don't want that in our cluster because if you have a malicious user in your cluster, they can actually use that container image for whatever the heck they want to use it for. So we want that out of here, right? And so what we're going to do is we're actually going to deploy Eraser into the cluster. And it's pretty easy to install that. Just a single YAML file that you can use to deploy. You can also deploy using a Helm chart, but this is easy enough for the demo. And so what it does is it actually installs a couple of different things in here. And it's fully configurable. And you can see that it's actually deployed a controller manager because almost everything in Kubernetes these days is all controller operator based. And so it installed the controller manager, and then it also installed this thing right here, the Eraser Scale 21 demo. So it's like the cluster name and that control plane. And you can see that there's going to be one pod, 3 containers, okay? The 3 containers is going to be, number 1, the collector. So it's going to gather up all the images that needs to be scanned. And then it actually has a scanner container, which will actually scan the containers. And then you have a remover, which actually deletes them out based on the scan results, okay? So they're all running right now, and they will run to completion, okay? There we go. So they've ran to completion, and they are now terminating. So I will go ahead and bounce out of that. And then I'll go and find my Eraser controller logs. There we go. And you can see that it deleted images, it deleted the pods, right? And then it's running job deletion, right? So you can see some of the things that it's doing along the way. And so now, if I run another command to verify that the unused images are gone, you can see now that I only have 1.2.2 because that's what I'm currently running on, okay? And just to show you a little bit of that configuration, this gets a little messy in my opinion because everything is all inside of a config map. But I do want to highlight here, within this config map, and let me just drop this down a little bit so you can see, there is this scanner config. You could enable it or disable it. If you disable it, it'll just delete all unused container images all the time, regardless of the scan results. Down here is where we actually configure the scanner. So you can see this actual configuration is a little bit different from when we ran the local Triviscan. So here it's looking for library vulnerabilities. So Copa will only patch for OS vulnerabilities. Eraser can actually delete containers based on any vulnerability, application or whatnot. And then here you're actually configuring the severities. And then, yeah, so that's basically it there. Okay, so that's pretty much it. So now we're at a point where we've automated the entire thing, right? From looking for vulnerabilities, patching that vulnerability, pushing it up to our container registry, and then using cool tools within the Kubernetes ecosystem to kind of automate that entire, I guess, distribution of that patched image. So that's pretty much all I had today in terms of the demo. And if I just jump back over here, what I would say is, just to summarize, I mean, containers are awesome. It's a great way to package your application and get those out into your, I guess, your server environments. But keeping up with container security is always challenging. But if you leverage open source tools, it could help ease that pain just a little bit, right? And secure supply chain is just one aspect, right? That's taking care of it from the building side of it. There is also runtime security that you have to worry about, and so that's a whole nother topic. With that, all I have for next steps is just a few links here to the CNCF projects. I would recommend everybody that's here and viewing online to go out to these projects, get involved, help out. This is why we love open source. To get everybody, the community involved and help build the product the way you need it to work. Also, there's a few things, few social things that I want you to follow here. I actually published a blog post this morning that'll walk you through the entire thing, so you can actually do it at home by yourself if you wanted to. Also follow my teammate, Josh Duffney. He actually did a lot of work on the secure supply chain as well, including signing your container images using Notary and then doing signature verification using Ratify, okay? Last bit here is we do have a open source Discord at Microsoft, so if you want, go ahead and scan that QR code and join the Discord community where you can chat with some of us folks here. So with that, that's all I had today. I would say I would open up to questions, and if not, thank you for your attention. Yeah, question.
Yeah, I have one. So we ran the cleanup to remove the images that contains vulnerability, but what is denying a malicious user to manually target a vulnerable image? Do we have an easy way to ban versions so not even manually is possible to target them and get them downloaded and used in our environment?
Yeah. So I'm not sure if I completely caught that question, but it's like how would you prevent folks from targeting very specific?
Yeah, we said 1.2.0 is vulnerable.
Yeah.
And we removed the local image.
Yeah.
But I can still modify a Docker Compose or Kubernetes configuration, whatever, to re-download that image.
Yes,
until it exists on a Docker registry that can be our registry or the Docker Hub registry. So do we have a way to, I don't know, a policy or something that as a high-level administrator I can block
That's where kind of like runtime security will come into play. Things like signing your container images, and then having something like in your Kubernetes cluster, like there's like OPA, gatekeeper, things like that. Because what you can do is once you have identified that that a specific version is vulnerable and you don't want to use it anymore, you could probably invalidate that signature so that when you go and pull down the container, it's going to say, no, we don't have that signature, we're going to block it, right? So that will be like runtime security against that, yeah.
I assume maybe you didn't show this just because it's complex and you're doing a demo, but are there ways to do staging before it gets to production after you've patched this image and maybe do a blue-green deployment or something to test it before you put it out at scale?
Absolutely. So Flux has this, and I'm only speaking from Flux because I have more experience over there, but Flux has this cool feature or capability called Flagger. It does exactly that. So Flagger will basically say, oh, there's a new image coming down. There's a new manifest update. So let me go and deploy that, but let me go deploy it as a separate deployment, right? And it's like a deployment of a different name because in Kubernetes, a service will point to a deployment. And so what Flagger will do is it'll deploy it as I guess, if we're talking blue and green, it'll deploy it as a green deployment, do its local testing using, I forgot what the internal tool is, but basically it'll start hitting that service and making sure that you have enough 200 requests, or passing requests. And then once it meets a certain threshold, it'll slowly start to pivot traffic to that new version. And then once it meets a certain threshold, it'll just cut over all traffic to that green deployment. So yes, within the cloud native ecosystem, you can do that. Yeah.
And then can you have these tools engage in signing as well? So if Copacetic triggers sort of, I'll call it a custom image, if you will, because it didn't come from the upstream.
So,
could you sign that just to indicate it came from this unusual source as opposed to the standard one, and maybe integrate that into the security features you've had based on signing?
Like have the signature point that it was patched rather than...
Right. Or that the patch tool was actually the signer of this, the originator, as opposed to the upstream's authoritative source.
Yeah, that's an interesting one. I'm not sure if any of the signing technology can do that, but my teammate Josh Duffney, he actually put together an article that's very similar to this demo, but rather than just patching and pushing, he patch, sign, then push, right? So then once it's signed up there, then it can pass the signature verification process at the cluster.
Yeah, it just strikes me that if you're an org using something like Trivy probably uses signing. The Venn diagram of those two things is almost going to have full overlap from what I've seen. And if it comes out of the system completely unsigned, most places would have policy that wouldn't actually let it to run aside from a demo.
Right, yeah. That would be an interesting one. Just sign it to the point where like, okay, this is patched. It's not the full, it shouldn't be your full image. You shouldn't be running this. You should eventually...
It's basically on a to-do list that you should look for an authoritative one with that patch later rather than run this thing forever.
Yeah.
Any other questions? Well, why don't you join me in thanking Paul for this great presentation?
Thank
you
really
all
well
done,
here.
Paul. Thanks.
Thank you so much.